All right, so picking up where we left off with this example. Again, we got through just the kind of simplest part of checking my given f of x for the changes in sign. We determined that there were 3 sign changes, therefore there would be 3 or 1 positive real zeros. When it comes time for us to identify the negative real zeros, remember what has to happen is that we're not going to search for f of x, but we're going to look at f of negative x. So, give me the lengthy delay here. Hold on 1 second. Oh, so they became unplugged. Outstanding. Glad we're doing all this on a video. All right. All right. There it goes. Okay. So, back to what I was saying here is that when it comes time for us to search for the negative number of zeros, again, we have to count the number of sign changes for f of negative x. So, still quite the delay here. There it is. Nothing like problems here. Okay, so we're looking at x to the 4th minus x cubed plus x squared minus 3x minus 6. I'll give a little bit more space, so I'm going to shift this downward just a little bit. Alright, so what we're saying we need to do is plug in a negative x everywhere that we saw in x, and then we're going to evaluate. Alright, so what that means for us, once again, is that negative x to the 4th power, that's going to become positive x to the 4th. Negative x cubed stays negative, but since we're subtracting, it becomes positive x cubed. Negative x squared becomes positive, we're adding it, so that's going to stay positive x squared. Negative 3 times negative x is positive 3x, and then if I were to subtract 6. So now that I'm looking at, remember, f of negative x, positive to positive to positive to positive to negative, there's only 1 sign change. So if there's only 1 sign change, then we know that there's exactly 1 negative real zero. Like that, okay. We don't know what they are yet, but we determined at the very beginning of this problem that if the degree is 4, that we know that we're going to have exactly 4 zeros. We might have some imaginaries in there, but we know that we're going to have 4 zeros. So if we were to consider it this way, knowing that our total, our target, I suppose, is 4 zeros, it is possible that if we have 3 positives, 1 negative, that there would be no imaginary zeros. If we had 1 positive, 1 negative, then I guess that means we're going to have 2 imaginary zeros. So as far as all of our possibilities are concerned, no, this is not our answer, but we know that we're going to have, in terms of positive real zeros, we're going to have 3 or 1. We absolutely are certain that we're going to have 1 negative, and then as far as the imaginaries, we're going to have 0 or 2. Okay, so from there, we now want to go ahead and find the actual zeros. So some of us might be thinking, for lack of a better term, this is now back to what we've been doing previously. So we have to create our list of P over Qs. Luckily, we have a leaf coefficient of 1. So that means that our P over Q list is going to be a little bit easier to identify. Looking at my constant of negative 6, its factors are plus minus 1, plus minus 2, plus minus 3, and plus minus 6. So again, this is my list of possible rational zeros. Now, one of the things that I like to do, problems like this, I think that you've already seen me do it, is I like to write them in order. So we've got negative 6, negative 3, negative 2, negative 1, 1, 2, 3, and 6. These are all of our possible zeros. There they are. That's what's going to happen. So from that list of 8, we're going to start doing some synthetic division. So as we do synthetic division, for this particular problem, I lost my place. Of course I did. There we go. For this particular problem, we're going to test one of these 8 values, and I've got a really good feeling about the number negative 3. Let's try negative 3. Weird place to start, you might be thinking, but got a method to my madness here. So we're going to test negative 3. As far as my coefficients are concerned, we've got 1, -1, 1, -3, -6. So 1, -1, 1, -3, -6. And now synthetically dividing these out, I drop the 1, multiply to get -3, add to get -4, multiply to get 12, add to get 13, multiply, excuse me, I lost my spot, multiply to get -39, add to get -42. Here, 1 second, multiply to get 126, add to get 120, and darn it, we missed. Oh, that's frustrating. We did not get 1. So -3, it's out. We're down to 7. But wait, we tested a negative root, and our final line was positive, negative, positive, negative, positive. So we found a lower bound. So since we found a lower bound, that means that not only is -3 going to be tossed out, but so is everything else that's less than -3. So -6 is gone. So unfortunately, no, we did not find a root. We did not find a 0. But with one round of synthetic division, we're able to toss out 2 possibilities. So our list just went from 8 down to 6. All right, so let's go ahead and try another round of synthetic division. This time, I don't know. Now I'm not even trusting myself. But let's go ahead and test +2. So if we test +2. All right, so same coefficients. We've got 1, -1, 1, -3, -6. Okay. So synthetically dividing these out, if I drop the 1, multiply to get 2, add to get 1, multiply to get 2, add to get 3, multiply to get 6, add to get 3, multiply to get 6, add to get 0, and I'm really excited about this. We found a 0. That's not the only reason why I'm really excited about this. Again, yes, that's the goal. We wanted to find a 0, we just got one. But also, we tested a positive value, and I got the final row of all positives. So that means that +2 is what we call an upper bound, which is outstanding for multiple reasons. Number one reason, once again, if we go back to our list, is that 2 worked. We got it. We found 1. But also, 3 and 6 they're out. So we've done 2 rounds of synthetic division. We found 1 0, and we've tossed out 4 others. So that means that where we started at 8, we're down to 3 options. And remember that we could continue on with synthetic division. We only have 3 options. I like those odds. Or we could continue on and do some factoring. Again, that's your decision. That's your call. I know that a lot of students prefer not to factor when it's cubic. So for that reason, I'm just going to keep on going, I suppose, with synthetic division. This time I'm going to test -1, see where we land here. Again, my final row that we had after that first round was 1, 1, 3, 3. So synthetic division this time, I drop the 1. We're going to multiply to get -1. Add those, we get 0. Multiply to get 0. Add to get 3. Multiply to get -3. Add to get 0. And once again, we're really excited about that. Again, for multiple reasons. We found another 0, x equals -1. Great. Yet we're about to stretch this about as far as you can stretch this. We have a negative value. We're going positive, 0, we're going to count that as a negative. Positive, 0, we're going to count that as a negative. So we are alternating with a negative c value. So once again, this would be a lower bound. Now, when we go back to our original list, that might be a little less impressive. Because when we find -1, now we only have 1 value that gets tossed out. But now also, process of elimination, again, we could utilize some theory here. We said at the very beginning that we're going to have 3 or 1 positive real zeros. So far, we've gotten 1. X equals +2. Is it even going to be worth our time to test +1? And the answer is no. Because if we have more than 1 positive real zero, we have to jump all the way up to 3. Okay? We found our 1 negative, and we're happy with that. That's great. But I think that we're at a point now to where we want to factor. We are down to a quadratic. We have x squared plus 3 equals 0. So if if I were to subtract the 3 over, if x squared equals -3, and we square root both sides, it's going to be x is equal to plus or minus. Now, remember, a couple days ago, we wouldn't be able to find the square root of a negative, but now if I factor the -1 out, that's I, root 3. Can't lose sight of the fact that that's plus or minus, so that means that we have 2. So as far as my zeros are concerned, since that was the real task, I know I was circling them as we went, but as far as the zeros are concerned, we found our first 0 in this particular problem at -1, we found a 0 at +2, we found a 0 at, and I'm totally fine with using plus or minus, but I'm trying to drive the point home here, I root 3, and at -I root 3. So these would be our 4 zeros that we were searching for. So again, everything that we're talking about today with Descartes' rule of signs and upper-lower bounds, it's just meant to speed up the process. It's just meant to help keep you moving. Notice some patterns and think about what that does for us. Think about how that helps you along. So, last problem that we've got here, 8x cubed minus 4x squared plus 6x minus 3. All right, so actually, I kind of started in a weird spot on this one. I started with the rational zero test, so I started with our P over Q stuff, but we are going to have to do that separately. Let me start with P values. Again, my constant -3, we're talking plus minus 1, plus minus 3. Our Q values here, with that leading coefficient of 8, you know, plus minus 1, plus minus 2, plus minus 4, plus minus 8. So we get to build quite a few P over Q values, which is great. Hold on a second. It should be coming. There it goes. P over Q's. All right, so I've got to put plus minus 1, plus minus 3 over each of these Q values. So when I put them over 1, luckily they don't change. When I put them over 2, got plus or minus 1/2, plus minus 3/2, plus minus 1/4, plus minus 3/4. Putting them over 8, plus minus 1/8, and plus minus 3/8. With the degree of 3, we're expecting 3 zeros. All right, so utilizing Descartes' rule of signs, first thing we want to determine is how many positive real zeros. So this is as simple as counting the number of sign changes. Positive to negative is 1, negative to positive is 2, positive to negative. There are, again, going to be 3 sign changes. Therefore, there would be 3 or 1 positive real zeros. Right as fast as I talk. All right, so off to the side, we're going to have to figure out for the negative real zeros, we're going to have to figure out what f of negative x is going to be equivalent to. It's supposed to be a negative x. Yeah, I better try that. Negative x. All right, so putting a negative x in place, this time we have 8, negative x cubed, minus 4, negative x squared, plus 6 to the negative, or times negative x minus 3. So I'm cleaning this up. Negative x cubed is going to stay negative times 8. That'll be negative 8x cubed. Negative x squared is positive times negative 4 is negative 4x squared. 6 times negative x would be negative 6x. Minus 3 doesn't change. So we have negative, 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 negative. There are no sign changes. Therefore, with no sign changes, that tells us that there are 0 negative real zeros. So now when I go back to our P over Q list that we've already created, as we can see, we had 2, 4, 6, 8, 10, 12, 14, 16 options. Because of this little nugget right here, we're down to 8. Again, without doing any work, we, again, would be foolish to test any negative real zeros. Again, we're not going to use synthetic division with any of the negatives because, once again, our Descartes' rule of sign tells us not to. It tells us that it's not going to happen. It's not going to show up. So, for our synthetic division, again, our coefficients of 8, -4, 6, -3. All right, what should we test? Yeah, I'm trying to cheat here. Yeah, I've got a good feeling about 1/2. Right, yeah, like that's ever one that I'm going to choose first. But if we were to test 1/2, just to show that we can do this with a fraction, bring the 8 down, multiply, we get 4, add to get 0, multiply to get 0, add to get 6, multiply to get 3, and we've got it. So our first 0 is at 1/2. The rest of this, 8x squared plus 6 equals 0. I'm going to subtract the 6 over. divide the 8 over, negative 6 8